Hi students. In this video, we're going to continue our discussion of naming compounds, but we're going to focus now on binary covalent. So binary, again, it's still two elements. Covalent, though, is going to be non-metal with non-metal. So the two elements are going to be non-metals, and that's on the right, upper right corner of your periodic table and to the right of that staircase. So we focused on ionic, it's a little tricky with charges, and now with covalent compounds, there aren't charges. They're actually sharing electrons through bonds. So we'll be looking at these types of molecules, sucrose. So what can we do to determine whether or not it's binary covalent? If the elements that are in the compound are on this side of the staircase, it's binary covalent. An exception, hydrogen can be over here. And all those are considered nonmetals. So binary covalent would be nonmetal with nonmetal. So what are the rules? We still list the more metallic element first. So the one that's furthest away from the noble gases is going to be listed first. There is an exception. You're always going to list the halogens before the oxygen. So basically, oxygen's always going to be last. The second element is similar, where we take the root of the second element. They're both nonmetals, but in this case, we're going to take the root of the second element, cut off the ending, and add the "ide" suffix, just like we did with ionic compounds. The difference is now, because there aren't charges, they're not ions, they're sharing electrons in a covalent bond, we can't use that to determine ratios. So what we have to use instead are prefixes. And the only time we won't use a prefix to determine the number of atoms in this covalent or molecular compound, because it's a molecule, is if the first element only has one. So what are the prefixes? Mono, everybody knows that's one. Di, tri, everything makes sense except tetra. You know, that doesn't, like, a lot of people think quad, right? Like quadrilateral or quadrisect. But tetra is basically, you could think of a tetrahedron. It's a four-sided figure. It's basically a pyramid with a triangular base, okay? After that, everything makes sense. Penta, you could think of the pentagon, right? So your pentagon. Hexa, hexagon, right? Think of a hexagon. Hepta, octa, like octopus, nona, deca, like decade. So these prefixes you're already familiar with. These are the ones I want you to know. So what are some examples? Okay, in the first example, we see chlorine dioxide. Notice we did not say mono. We did not put the mono prefix here because for the first element, if there's only one, we do not use a mono prefix. That's why this is just called carbon monoxide. So for the first element, if there's one, you don't use a prefix. That's the only time. So that would be carbon monoxide. This is carbon dioxide. We don't call that monocarbon monoxide. Okay, so the first element does not have the mono prefix. Now, the second element, di, there's two. So this is a dinitrogen because there's two. So you have to have a prefix for the first element. The only time you don't is if there's only one. So there's two, so we do dinitrogen, write out the full name. Pent, because there's five. Notice we dropped the A because it's in front of the O. Pentoxide. So dinitrogen pentoxide. Typically, when you have an A, like in penta or tetra, you're going to drop it in front of the O in oxide. Also notice that the nitrogen is the first element because oxygen is going to be last. The one furthest away, typically from the noble gases, with the exception between halogens and oxygen, like in this case here. Pretty self-explanatory. So maybe we could try these. So I'll give you a moment to think about that. Maybe put pause, you can write it down. So if we look at this, we have dichlorine heptoxide. So the hepta is 7. Then we have, it's not monocarbon, it's just carbon, but there still has to be at least one tetrachloride. And then dinitrogen difluoride. Remember the U before the O in fluoride. So the main difference between the binary ionic and the binary covalent, if you have a metal, right? So when will you know if it's ionic? When will you know if it's covalent? You know if it's ionic if you have a metal and a non-metal. That's when you use charges to determine ratios. So as soon as you see a metal and a non-metal, a light bulb should go off in your head and you're thinking ionic. I have to think about charges to get the correct ratio. If it's a non-metal with other non-metals, there are no charges. There's no ions. Why? They're sharing electrons. Okay? Those are those covalent bonds. They're sharing electrons. Here, there's a complete electron transfer, right? So if you watch the octet discussion video, we see that sodium has 1 valence electron. Chlorine has 7 because it's in group 7A. What does sodium do? It gives that 1 electron to chlorine, ends up producing a positive charge, and then the chloride has an extra electron. I could circle that extra right there. That sodium gave it and has a negative charge. So it's not sharing electrons. There's a complete electron transfer in ionic. So that's why there's charges. Covalent, there's no charges. They share electrons. So how do you determine the ratio since there's no charge? Prefixes. So that's how you have to remember. As soon as you look at a formula, you should see, is it ionic or covalent? If it's covalent, you're going to need prefixes. That's why we did it here. Because nitrogen and fluorine are both nonmetals, we need to use prefixes. And we did. So I hope that makes sense. If you guys have any questions, go ahead and leave them for me. And thanks for watching.